When you look up at the night sky, even briefly, there is often a sense of calm that comes with it. The darkness feels quiet rather than empty, and the stars appear like distant companions rather than unreachable objects. For most of human history, this view brought comfort. The sky felt like a familiar ceiling above the world, unchanged and dependable, watching silently as generations lived and disappeared beneath it. Thousands of years ago, the universe felt large, but it also felt understandable. The stars were seen as neighbors, fixed in place, returning night after night in predictable patterns. They guided travelers across land and sea, marked the seasons for farming, and became the foundation of stories that helped people explain their place in the world. Even when the sky was filled with myths and gods, those stories made the universe feel personal and connected to human life. In that earlier view, humans felt small, but not lost. There was a quiet belief that although the universe was vast, it was still somehow arranged around human experience. The earth felt central, the sun felt purposeful, and the stars felt like part of a grand but understandable design. The universe did not feel indifferent. It felt like something that noticed us. As science slowly advanced, that sense of comfort remained. Early telescopes revealed more stars and deeper layers of space, but each discovery still fit within a framework people could imagine. Even when galaxies were discovered and distances expanded beyond anything previously known, there was still a sense that the universe had limits. It felt like a puzzle that, given enough time and observation, could eventually be solved. This belief made the night sky feel safe. It became a place of curiosity rather than fear. People could stand beneath it and feel awe without feeling overwhelmed. The universe appeared orderly, structured, and stable. Nothing seemed to rush away. Nothing vanished without explanation. The stars stayed where they were supposed to be. Take a slow, gentle breath here. Not deep, just easy. Then let it go. That calm came from familiarity, and familiarity comes from boundaries. For a long time, humanity believed those boundaries were within reach. The universe was enormous, but it was thought to be measurable, mappable, and ultimately knowable. There was comfort in believing that reality had edges, even if we had not yet found them. In that illusion of closeness, the stars felt like distant neighbors rather than unreachable strangers. The night sky watched quietly, offering beauty without demanding answers. For thousands of years, the universe felt big, but understandable. That feeling stayed with us for a very long time, until we learned how to see the darkness differently. And that is where this story truly begins. Before we drift into the stars, take a moment to support this journey. If you enjoy exploring the universe with us, gently tap like, share this video with someone who loves the cosmos, and subscribe to join our quiet voyage through space. Let's explore the unknown together. Before the James Webb Space Telescope began sending back its images, our understanding of the universe felt settled. Not complete, but comfortable. For decades, the Hubble Space Telescope had been our primary window into deep space, and through it, we learned to see the universe as vast, yet surprisingly organized. Hubble showed us galaxies in stunning detail. Spiral galaxies with graceful arms, glowing elliptical galaxies, and distant clusters floating in dark space. These images reshaped how humanity understood its place in the cosmos, but they also reinforced a sense of structure. Galaxies were far away, unimaginably distant, yet still countable. We could estimate how many existed within the observable universe and place them into categories that made sense. The observable universe itself felt finite. It had a size. A measurable boundary defined by how far light had traveled since the beginning of time. Beyond that edge, there was uncertainty, but within it, scientists believed we had identified most of the large-scale features. Galaxy clusters, superclusters, vast cosmic filaments, and enormous empty voids all seemed to fit neatly into our models. There was reassurance in that knowledge. The universe appeared to have a clear architecture. Matter gathered into predictable shapes. Gravity behaved as expected. Time flowed forward in a way that allowed galaxies to slowly evolve, collide, and change. Nothing about the large-scale universe felt rushed or chaotic. Hubble's most famous images, like the deep field photographs, showed thousands of galaxies packed into tiny patches of sky. Even then, the discovery felt astonishing rather than disturbing. Each deep field expanded our sense of scale, but it still suggested that the universe was something we could chart. Each new observation filled in another piece of a map we believed was nearing completion. Scientists genuinely thought we were close to understanding the universe's overall structure. The major components were believed to be identified. Dark matter and dark energy were mysterious, but they were already accounted for in our equations. The universe felt like a system with known rules, even if some details were still missing. This created a quiet confidence. A sense that humanity was progressing steadily toward a complete picture of reality. The universe might be vast, but it no longer felt unknowable. It felt like a place we were slowly, patiently learning to understand. There was comfort in that idea. The cosmos seemed stable, measured, and familiar. A place where the biggest discoveries had already been made, and what remained were refinements rather than revelations. And then, a new telescope prepared to look at the same sky, and see something entirely different. When the James Webb Space Telescope was launched, it was not meant to replace Hubble. It was designed to see the universe in a completely different way. While Hubble observes mostly visible and ultraviolet light, Webb was built to detect infrared light, a form of radiation that behaves very differently as it travels through space. Infrared light allows Webb to see what other telescopes cannot. As the universe expands, light from distant objects stretches, shifting out of the visible range and into infrared wavelengths. This means that some of the oldest and most distant galaxies are effectively invisible to telescopes like Hubble. Webb was designed specifically to capture that stretched, ancient light. This difference alone changed everything. With infrared vision, Webb could look through thick clouds of cosmic dust that normally block visible light. Regions that once appeared dark and empty suddenly revealed stars being born, galaxies forming, and structures hidden for billions of years. What once seemed like voids were no longer empty at all. There is another important difference in how Webb sees the universe. Because light takes time to travel, looking farther away also means looking further back in time. Webb was built to observe the faint glow of galaxies that formed shortly after the universe began. In some cases, it is capturing light that has been traveling for more than 13 billion years before reaching us. This means Webb is not just a powerful telescope. It is a time machine. Each image it sends back is a snapshot of the universe as it existed near the beginning of everything we know. Take a slow breath here, and let the idea settle. But Webb does not simply look farther into space. It looks deeper into reality itself. Its sensitivity allows it to detect extremely faint objects, revealing details that were once completely hidden. Entire populations of galaxies, previously unseen, now appear in regions of space we thought we understood. Where older telescopes showed darkness, Webb shows structure. Where we expected emptiness, it reveals complexity. The universe begins to look less like a quiet, orderly place and more like something layered, dense, and endlessly detailed. This new way of seeing quietly disrupted everything scientists thought they knew. The same sky. The same directions. But a completely different picture emerged. And with that picture came a realization that the universe was not just bigger than expected. It was deeper, older, and far more crowded than anyone had imagined. When the first full images from the James Webb Space Telescope were released, the reaction was immediate and intense. At first glance, they looked beautiful, even familiar. Glowing galaxies, soft colors, and distant points of light scattered across a dark background. But as scientists began to study the images more closely, something unsettling became clear. Webb was pointed toward regions of the sky that had already been observed many times before. Areas that were thought to be mostly empty. Patches of darkness between known galaxies, assumed to be quiet stretches of space with very little inside them. These were places where older telescopes had seen almost nothing at all. Webb saw something very different. In image after image, those dark regions were filled with galaxies. Not a handful. Not a few faint smudges. But thousands of distinct galaxies packed into spaces that once seemed nearly empty. Every tiny point of light was not a star, but an entire galaxy, each one containing billions of stars of its own. The scale of what Webb revealed was difficult to absorb. Where scientists expected to find a small number of distant galaxies, Webb uncovered vast populations stretching far beyond previous limits. The universe was not thinning out as we looked farther away. It was becoming denser. This discovery quietly changed the way scientists thought about cosmic distance. If every seemingly empty patch of sky was filled with galaxies, then the universe was not offering us clear boundaries. It was not fading into nothingness. It was continuing, layer after layer, without visible end. Take a slow breath here. The more researchers examined the data, the more troubling the implications became. Some of the galaxies Webb detected were far older and more developed than expected. According to existing models, they should not have had enough time to form, grow, and organize themselves so early in the universe's history. Yet there they were, fully formed, massive, and complex. Each of those galaxies held billions of stars. And around many of those stars, there could be planets. Worlds. Entire systems unfolding silently across unimaginable distances. The number of possible places in the universe multiplied beyond anything previously imagined. What began as awe slowly turned into unease. Not fear, but a quiet sense of disorientation. The comforting idea of a universe that gradually thinned out as we looked deeper into space no longer held true. Instead, every direction revealed more structure, more light, more matter. There was no edge. Only more. The universe did not seem to be opening into emptiness. It was opening into itself, endlessly repeating complexity on scales that defied intuition. The more clearly we looked, the less final the picture became. And with those first images, it became clear that the universe we thought we were mapping was only a fraction of what was actually there. As scientists continued analyzing the data from the James Webb Space Telescope, a deeper problem began to emerge. It was not just that the universe appeared larger than expected. It was that it seemed to have grown too quickly, in ways that current theories could not easily explain. According to long-standing models of cosmology, the early universe should have been chaotic and slow to organize. After the Big Bang, matter was expected to take time to clump together under gravity, gradually forming stars, then galaxies, and eventually the large structures we see today. This process was thought to take billions of years. Webb challenged that timeline. The telescope detected galaxies that existed extremely early in the universe's history, yet appeared far too massive and well-organized for their age. These were not small, irregular collections of stars just beginning to form. They were large, structured galaxies with clear shapes and dense populations of stars. Some were forming stars at rates far higher than models predicted should be possible. This created what scientists now refer to as a scale problem. The universe seemed to have built complexity much faster than expected. Galaxies grew large before they should have. Structures appeared mature before there should have been enough time for them to develop. Take a moment here. Let that idea settle. The issue was not a single unusual discovery. It was a pattern. Again and again, Webb's observations showed galaxies that did not fit neatly into existing explanations. The universe was not just expanding. It was organizing itself rapidly, efficiently, and on enormous scales almost immediately after its beginning. This forced scientists to confront a difficult possibility. Either something fundamental about the early universe was misunderstood, or the models used to describe cosmic growth were incomplete. In either case, the comfortable sense that the universe followed well-understood rules began to soften. Importantly, this did not create panic. It created calm confusion. The data was clear, but its meaning was not. The universe was behaving consistently, just not in the way we had expected. It was as if reality had been following a set of rules we had only partially uncovered. Some theories suggest that star formation may have been more efficient in the early universe. Others propose that dark matter behaved differently at the beginning of time. There are even suggestions that our understanding of gravity itself may need refinement on the largest scales. None of these ideas are settled. And that uncertainty is what makes this moment significant. For the first time in decades, scientists are facing evidence that the universe may be larger, faster, and more capable of complexity than our most trusted theories allow. The universe is not broken. But our understanding of it may be incomplete. And as Webb continues to look deeper, the scale of what we do not yet understand continues to grow quietly alongside what we do. As the scale of the universe becomes clearer, another realization quietly settles in. It is not just that the universe is larger than we thought. It is that we are not near the middle of it in any meaningful way. Earth orbits the Sun. The Sun is one star among hundreds of billions within the Milky Way galaxy. The Milky Way itself is only one member of a local group of galaxies, drifting together through space. That group is part of a much larger cluster, which in turn is connected to vast filaments stretching across the universe. Each step outward moves us farther from anything that could be called central. There is no single location that stands out as special. No point in space that everything else revolves around. No place that feels chosen or favored. Every galaxy appears to be moving away from every other galaxy, carried along by the expansion of space itself. This realization is not sudden or dramatic. It unfolds slowly. The more distance we trace, the less meaningful our position becomes. The universe does not seem arranged around us. It does not pause at our location or bend toward it. Take a slow breath here. Even the idea of a center becomes difficult to define. The universe does not expand into empty space from a single point. Space itself is expanding everywhere at once. From any location, it looks as though everything else is moving away. From any galaxy, the view would appear much the same. There is no marker in the sky that says, "This is where it all begins." No reference point that confirms our importance. The universe offers no sign that it notices where we are. This distance is not hostile. It is indifferent. The universe does not reject us. It simply continues, unfolding in all directions without preference. And in that vast, drifting motion, Earth remains what it has always been. A small world orbiting an ordinary star, in a galaxy that is not remarkable, in a region that is not central. The universe does not seem to care where we are. And yet, we are here, quietly observing it, from a place that is nowhere near the middle of anything. As the universe grows larger and more distant in our understanding, another realization begins to take shape. Everything we can see, every star, every planet, every glowing galaxy revealed by James Webb, represents only a small fraction of what actually exists. Most of the universe is invisible. Scientists estimate that about 95% of the universe is made of things we cannot see directly. Dark matter and dark energy dominate reality, shaping everything we observe, yet never revealing themselves in a clear or tangible way. Dark matter does not emit light. It does not absorb it. It does not reflect it. Telescopes cannot photograph it, no matter how powerful they become. And yet, without dark matter, galaxies would not exist in their current form. Stars would fly apart. Cosmic structures would never have formed. Something unseen is holding everything together. We know dark matter is there only because of what it does. Galaxies rotate too fast to be held together by visible matter alone. Clusters of galaxies bend light more strongly than they should. Something massive, something invisible, is present in vast quantities, quietly shaping the universe from behind the scenes. Take a slow breath here. Dark energy is even more mysterious. It appears to be responsible for the accelerating expansion of the universe. Instead of gravity slowing cosmic growth, space itself is stretching faster and faster over time. Galaxies are not just drifting apart. They are being pushed away by something we do not understand. Dark energy does not clump like matter. It fills space evenly, exerting its influence everywhere at once. And once again, we cannot see it directly. We only notice its effects, measured through careful observation and mathematical inference. This creates a strange imbalance in our understanding of reality. Everything familiar, everything visible, everything we experience firsthand makes up only a small portion of what exists. The majority of the universe remains hidden, detectable only through its influence on things we can see. There is a quiet unease in that realization. Not fear, but a soft discomfort. The sense that most of reality operates beyond our perception. That the universe we experience is only a surface layer covering something far deeper and largely unknown. Most of reality never reveals itself. James Webb shows us more light than ever before, but it also sharpens the contrast between what is visible and what is not. The clearer our images become, the more obvious it is how much remains unseen. The universe is not just vast in size. It is vast in mystery. And much of what shapes it will likely never announce itself directly, continuing its work in silence, holding everything together without ever stepping into the light. The universe is not static. It has never been static. From the moment of the Big Bang, it has been expanding, stretching the fabric of space itself in all directions. Galaxies drift apart, carried along by this expansion, and nothing we do can slow it. Even the strongest gravitational pull is powerless against the steady growth of space. This expansion is not uniform in a simple way. In some regions, space stretches more rapidly than in others. Entire galaxies, clusters of galaxies, are moving away from us at incredible speeds, pushed by the invisible force of dark energy. The further they are, the faster they drift, until eventually they will disappear from view entirely. Light emitted by those distant galaxies will never reach us. They will move beyond the horizon of what is observable. Take a slow breath here. Let the thought settle. Space is stretching, carrying entire worlds and billions of stars quietly away from each other, and we can only observe a fraction of it. In the future, observers on Earth or on planets in other galaxies will see less than we do now. The universe will appear emptier, as more and more galaxies fade beyond reach. What is visible today is a fleeting opportunity. Our position in cosmic time allows us to witness a universe richer and more full than any observer billions of years from now will ever see. This is not a dramatic event. It is slow, imperceptible on human timescales. Yet the effect is inevitable. The universe is quietly erasing its own evidence, stretching itself into regions we can no longer touch with our senses or our instruments. What seems permanent, the stars, the galaxies, the cosmic structures we observe, is actually moving steadily out of reach. And in that quiet stretching, the universe continues its work, indifferent to our observation. Galaxies form, evolve, and drift apart, as space itself grows larger, faster, and emptier. We are witnessing a moment in cosmic history that will never repeat, a window of time in which the universe is still accessible enough for us to study. Take another gentle breath. Let the idea linger. The universe is immense, expanding, and in the process, slowly hiding parts of itself from any future observers. What we see today may be all that will ever be available to us, a fleeting glimpse of a vast, unstoppable motion. When we step back and consider everything James Webb has revealed, it becomes clear that our place in the universe is both small and fleeting. Our lives are brief signals in the vast expanse of space and time. Every thought, every action, every story we tell occurs in a tiny corner of a universe that stretches in all directions far beyond our comprehension. And yet, despite the scale and complexity, the universe has allowed us to see it. We are aware. We can look up at the stars, study distant galaxies, and trace the light from billions of years ago. Awareness itself is remarkable. In a universe so vast, so indifferent, consciousness exists, briefly, quietly, like a flicker of light in an endless night. Our understanding is limited, but that limitation does not diminish its wonder. Even as we grasp only a fraction of what is out there, that fraction is enough to inspire awe, reflection, and curiosity. We have learned to measure distances, detect invisible forces, and watch galaxies forming near the dawn of time. The universe is immense, but in some way, it has offered us the chance to witness its magnitude. This perspective brings a peaceful kind of insignificance. We are small, yes, and our time is short, but that does not make us unimportant. It makes our awareness a rare and precious occurrence. We are brief observers in a cosmic story far larger than ourselves, and our ability to perceive even a tiny portion of it is extraordinary. Take a slow, gentle breath. Let that thought settle. The universe continues its expansion, its processes unfolding silently over billions of years, indifferent to us, yet permitting us to watch, to think, to wonder. Our existence may be fleeting, our influence limited, but our awareness is a quiet miracle in the midst of incomprehensible scale. We are, in this sense, fortunate. The universe may not care where we are, but it has allowed us a glimpse of its vastness. And that glimpse, however small, is enough to inspire reflection, curiosity, and a sense of connection to everything around us. And now, as we come to the edge of this journey, we return to silence. The universe does not threaten. It does not rush toward us. It does not demand attention or recognition. It simply continues, quietly, steadily, in ways too vast and slow for our minds to fully grasp. Space stretches. Galaxies drift. Light travels across unimaginable distances. Stars are born, live, and die, all without pause, all without concern for us or our brief moment in time. And yet, we are here to watch. We are here to notice, to observe, to breathe alongside it. Take a gentle breath now. Feel the stillness. There is nothing urgent. Nothing to fix. The universe continues its expansion, indifferent yet constant, and we drift within it, carried along silently. The universe doesn't scream. It expands, quietly, and we drift with it. And in that quiet, there is a sense of peace, of belonging, even in the vastness, even in the unknown. The darkness is not empty. It is simply there, and we are part of its flow.